I'm going to talk about parametric analysis of equations in high school physics. And this is where you have a question that's like this. Kinetic energy is, well, let me just phrase it like this. What happens to some variable when I triple or double or half or quadruple some variable here? Okay, so what happens to one variable when I change another variable in a certain way? Okay, well, if we have a graph of the first variable and the second variable, right, and maybe it does this, what you could do is you could figure out, here's one value, and then if you triple it, you can look up on there what the other value is, and the difference between those two things would be, or I should say the ratio between these two values would be the effect. So what happens to this y value when I triple the x value? Well, it looks like it goes up, I don't know, 2.5 times, something like that. So that's the kind of answer you'd come up with. It increases by a factor of 2.5, 2.5. That's the kind of answer you could get for this. Or they could give you the initial value of this, and you would say, oh, okay, 2.5 times that, and you'd figure out what the final value is. I want to show you how to solve that. I'm going to show you two different ways of doing that. Okay, and I'm going to use kinetic energy as an example, and kinetic energy is 1/2 mv squared. And I'm going to say what happens to the kinetic energy when I triple the velocity. And you could do this from triple the mass or triple the velocity. You can do it with very, very much more complicated equations. But I'm going to do it two different ways. And the first way is just manipulating the equation. And the second way I call fake numbers. It's plugging in token numbers for each of these problems. So first way, what I do is I say, okay, kinetic energy is 1/2 mv squared. That's what I'm going to start with. I want to find out what my new kinetic energy would be. And I'm going to call that Ke prime if I make the velocity 3 times as big. So 1/2, the m doesn't change. And what I'm going to do here is I'm going to say, okay, woo, that's a little different than what I expected. But you can see how it changes. Okay, instead of the initial velocity being squared, no, it's 3 times that initial velocity being squared. We could even write that as v prime. Let me make that thinner, holy cow. I could even call this v prime right there, which is 3 times the initial velocity. Okay, so now when I rewrite that equation, this is 1/2 times m times 3 squared times v squared. I do want to write this in a different color. 3 squared is 9 v squared. And then I want to take this guy and pull it out front. I want to make this equation look as much like the original as possible. And the way I do that is there's the 9, just rearranging 1/2 mv squared. So you can see it's now 9 times the original kinetic energy. So we can say my new kinetic energy will be 9 times the old one. So increased by a factor of 9. That's one way to do it. Okay. Another way they could ask is they could say a cart has a kinetic energy of 8 joules. What would happen if it had 3 times as much velocity? Well, we'd say, okay, my final kinetic energy would be whatever I said for this, 8 times 9, 72. So you'd still do the same thing, and you can do it without any numbers other than this coefficient, what it's changed by, what the velocity is changed by, and it allows you to find the effects on the kinetic energy. Okay, that's the first way of doing it. I'm going to show you another way, and this is called, I call it just fake numbers. So if you're comfortable manipulating like this, fantastic. Fake numbers, think if you were in a lab or something like that, and you say, I'm going to get that initial, well, I'll just call it before and after. Well, let's call it initial and new. Okay, initial, baseline, baseline case. Initial and new kinetic energy. Okay? So pretend you're in a lab. You can do an experiment. What happens if you triple the velocity? Well, let's control everything else. I'm going to get a 1 kilogram cart, and I'm going to give it a velocity of 1 meter per second, and I'm going to measure the energy somehow. Okay? And my energy meter will tell me that the kinetic energy is 1/2 times the mass, 1, times the velocity, squared, is 1/2 joule. My new, if I change that, I'm going to keep that, do that same cart, but now I'm going to go 3 times as fast, 3 meters per second. And I plug that in. KE equals 1/2 times 1 times 3 squared. The mass hasn't changed, right? So this ends up being 4.5 joules. And when you compare this to my initial one, this is 9 times as big. So that's another way to do it, is fake numbers. I'm going to do an example of each of those with a much harder problem. Okay, and the much harder problem is going to have to do with gravitation. And if you're in my class right now and you're learning kinetic energy and you're seeing this, you don't know this equation. I'm just going to tell you that it exists. Fg equals gm1 m2 over r squared. And I'm going to say, what happens? This is going to be the biggest, ugliest one I can think of. What happens to the force of gravity if both masses are doubled and the distance between them, which is this r, is tripled. Let's do tripled. Okay, so a big ugly thing. You may not be able to look at that equation and say what's going to happen. So I'm going to do it the first way. The first way, once again, I'm going to write down my new one, Fg prime. I want to find out what that's going to be. G is a constant. Capital G is a constant. M1 and M2, we're doubling both of those. So let me write this R squared. Okay? We're going to double both of those. So this is now 2 times as big as it was. I really have to stop doing that. Let's try this. Is that going to work? Yeah. Oh, I want a different color there. Okay, 2 times M1. And my new M2 prime is going to be 2 times my initial M2. And this is going to be 3 times as big. And you got to remember that you got to group that to square it. Okay, so let's see what we got. Well, G times M1 times M2 times 2 times 2. 3r times 3r is 9 times r squared. This was my original force of gravity. So it's going to end up being 4/9 times the original force of gravity is my new, my Fg prime. So it changes by a factor of 4/9. Okay, let's try it with fake numbers. Initial or before or unchanged in new. Okay, so I'm going to get in the lab. I'm going to get 2 masses. And I'm going to, again, pick one for these things. It makes the math so much easier. By the way, G is a big ugly thing. I'm just going to leave that as G. And I'm going to put them 1 meter apart, and I'm going to see what the force between them is. And it's going to be this number G times 1 divided by 1 squared is just G. then I come over here and I say, okay, I'm going to do that same experiment, but I'm going to use twice as much mass for each of these, 2 kilograms. I'm not writing the units, but you get the idea. I'm going to use 3, or I tripled it. If it was 1, now it's 3. And then I say, okay, so my new, I'll put the prime there just to be consistent, is going to be G times 2 times 2. I'm just using this equation right there. G times 2 divided by 3 squared, and that is 4/9 G. So you can see from there to there, it changed by a factor of 4/9. A common way a question like this might be asked sometimes confuses people. Okay, we could say the force of gravity between them, between 2 objects, is, I don't know, 64 newtons. Then, what happens if both masses are doubled and R is tripled? Notice, I don't even need to use this in either of these 2 approaches to draw a conclusion, because I can draw a general conclusion. Anytime you double both masses and triple R, the new force of gravity will be 4/9 of what it was before. So I can simply say Fg prime will be 4/9 of what it was before, 64. And you multiply that out, and you have your new force of gravity. So there's actually a little discipline required. When you see this here, don't be fooled. You don't start plugging things in here. You say, anytime you see it as a parametric problem where it looks like this kind of thing, what happens if you double this and triple this is find out the general rule for if you double it and triple it. What happens? Oh, 4/9 times whatever it was before. Then apply it to that initial number that they gave you.